Today our first lecture. Today we will consider three topics. Such topics such as basic definitions and the terminology, and first order differential equations, and separable variables, homogeneous and homogeneous equations. What is differential equation? The word differential and equations certainly suggests solving some kind of equations that contains derivatives y prime, y2 times prime, and so on, and also occurs in algebra, and as we know, in which good amount of times is spent solving equations such as x squared plus 5x plus 4 is equal to 0 for unknown number x. In our course, one of our main topic is solving equations with derivatives. So, for example, here y2 times prime plus 2y prime plus y is equal to 0. And in this case, solution of this kind of differential equations will be function dependent on some variables. In this case, we know that y is a dependent variable and x is independent variable. Okay, so what is a differential equation? Let's give a definition of differential equations. An equation containing derivatives of one or more unknown functions or dependent variables with respect to one or more independent variables is said to be a differential equation. So when we talk about differential equations, we classify our differential equations according to type, order, and linearity. Classification by type. If differential equation contains only ordinary derivatives of one or more dependent variables with respect to single independent variable, it is said to be ordinary differential equation. So, for example, let's consider here examples. So, in the first example, you see dy equation dy over dx plus 5y is equal to ex. This differential equation is ordinary differential equation. Why? We have dependent variable our y and the independent variable and x. So here just we have derivative by just x. So that this differential equation will be ordinary differential equation. So here also we see here second derivative, but also our derivative depended just a single variable. So in this case here we have two dependent variables. Here our dependent variables x and y, and but these functions depended on t, so that since here we have just derivatives by t, this differential equation will be ordinary differential equation. Partial differential equation. An equation involving partial derivatives of one or more unknown functions of two or more independent variables is called partial differential equation. Okay, so let's consider examples. So the following equations are partial differential equations. D square u over dx square plus d square u over dy square is equal to 0. This differential equation is partial differential equation because here we have partial derivatives. We can say that if in our differential equation consists partial derivatives, we say that our differential equation is partial differential equation. So here we see that d square u is a function dependent on x and y, so that here can take its partial derivative by x and the partial derivative by y. Here we see in the second equation we have d square u over dx square is equal to d square u over dt square minus 2 du over dt, and here we see u is function dependent on variables x and t. So, and here we have partial derivatives. So in the third equation, note that there are two unknown functions and two independent variables. This means that u and v must be functions of two or more independent variables. Okay, so Next classification is classification by order. The order of differential equation is the order of highest derivative in equation. For example, we have this equation. We see that this differential equation is ordinary differential equation because here we have ordinary derivatives. So order of this differential equation is 2, and we say that this differential equation is second order ordinary differential equation. Separable equations. First order differential equation of the form dy over dx is equal to g at x multiplied by hx is said to be separable or have separable variables. So, in other words, if we can write our differential equation in this form, here g at x is a function dependent on x and hy is a function dependent on y. If we can write our differential equation in this form, we say that our differential equation is separable differential equation. For example, in this case, the equation dy over dx is equal to y squared x e of power 3x plus 4y. Can we say this one is separable equation? So let's check. Can we write this differential equation in the form g at x multiplied by hy? So in this case will be g at x is equal to x e of power 3x. Here our g at x will be this function, and our hy will be y squared multiply e of power 4y. So second example, here dy over dx is equal to y plus sine x. So it is clear that we cannot write our differential equation in the form g at x multiplied by hy, because here we have sum of functions, and it's clear that we can't write these functions as multiplication of two functions such that one function depends on x and the second one is dependent on y. So that this second equation is not separable differential equation. To solve this differential equation, firstly we need to check is this differential equation separable or not. If we divide this differential equation by dx multiplied by 1 plus x, we will obtain dy over dx is equal to y over 1 plus x. This function is the multiplication of two functions such as y and 1 over 1 plus x. So in this case hy is equal to y and g at x is equal to 1 plus x. Okay. So if we divide this equation by 1 plus x multiplied by y, if we divide our differential equation by this factor, we can write this differential equation in this form. dy over y is equal to dx over 1 plus x. If we take integral from right side and the left side, we have integral dy over y is equal to integral dx over 1 plus x. From here we know that integral of 1 over y is equal to ln y, and the integral of 1 over 1 plus x is equal to ln 1 plus x. We have y is equal to ln 1 plus x plus c1. And we can write this plus by multiplication e of power c1. E ln 1 plus x will be 1 plus x, and multiplied by e of power c1. Okay, since we have here module, absolute value, so it means that y is equal to plus minus e of power c1 multiplied by 1 plus x. Relabeling plus minus e of power c1 as c, we can write y as is equal to c multiplied by 1 plus x. And the solution of our differential equation will be y is equal to c1 plus x.